Good morning, class, and welcome to this lesson on Electrostatics 11, Capacitance. Today, we will be able to describe capacitance and how it is related to charge and voltage. Um, Here we go. Think of capacitance, oops. Think of capacitance as kind of like maximum occupancy, okay? We know that a capacitor stores charge. If we connect this to a battery, which is not, it's not shown here, it's not shown here. This battery will remove, oops, wrong way. This is the positive side, positive, negative. This battery is going to remove electrons from one side and put it on the other. Oh, which by the way, I don't think I said this before. The charge on both plates is the same. The charge on both plates is the same, because the amount of electrons that are pulled off this plate go on this plate. So these are equal and opposite charges on both sides of the plate. That's intuitive, but I just want to say to be safe. Okay. So back to our discussion. Capacitance. Capacitance is like maximum occupancy. Okay. We can have a room. We can have a room, right? And the maximum occupancy could be 40 people for the room. And depending on what the room is being used for, there could be 20 people in the room, but the maximum occupancy is still 40. So the capacitance will not change, will not change based on charge. Okay, the capacitance will not change based on charge. We could have, 1 times 10 to the negative ninth coulombs on a plate. We can have 1 times 10 to the negative 6 coulombs on a plate. But either way, the capacitance is still the same. Okay, a stronger battery will fill up the other plate. So a stronger battery will get the capacitance to maximum occupancy, but the capacitance doesn't change. Only charge and voltage change. So this is where we get our equation, where capacitance is equal to charge over voltage. Okay? Or a more common form of the equation, actually, charge equals voltage times C. Okay, a little bit easier to work with that way sometimes. Get rid of the fraction. So this value does not really change. Okay, this value does not change if everything is held constant. If everything is held constant, this value will not change. Okay, so if we have a stronger battery, if voltage goes up, then the amount of charge stored goes up. If we have a weaker battery, if voltage goes down, then charge goes down. And you can see these are related in the equation. So capacitance will be a constant number. Okay, based on the capacitor. Okay, and every capacitor has different capacitances based off how they're made. Okay, so capacitance doesn't change. And capacitance actually has another form of the equation. We can more specifically calculate the capacitance of a capacitor, which, say that 5 times fast. C equals K epsilon naught area over D. So the capacitance of a capacitor is affected by the dielectric constant, which, don't worry about that for right now. That's going to be our next video. Just know it's a constant for right now. This epsilon naught is called the permittivity. Make sure I spell this correctly. Permittivity of free space. It is also another constant, and its value is 8.85 times 10 to the negative 12 coulombs per newtons meters squared. Okay, you don't have to memorize this. This is typically will always be given to you as a constant. This is the area of the plates. And this is the distance between plates. So I said that capacitance was always constant. Well, that's if these things remain constant. If these things remain constant. If we are able to increase the area of the plates, if we are able to increase the area of the plates, that means capacitance will go up. You can see these two are directly related, okay? Bigger plates mean more capacitance, okay? If we decrease the area, capacitance goes down, okay? They're directly related. Likewise, if we are able to take these two plates and move them closer together, so if the distance is smaller, if distance goes down, capacitance goes up. And if distance goes up, capacitance goes down. So this is an inverse relationship, okay? And this is a direct relationship. So more often than not on this particular topic, when you're getting to test time, especially in AP Physics, what you're going to find is that in general, you're going to be given questions like, if we were able to increase the area by 3, what's going to happen to the capacitance? If we can decrease the area by 5, what's going to happen to the capacitance? And so you have to understand the relationship between these two. So that's actually pretty simple. Okay? Now, I'm going to do one more thing, because also another common question is this. We have two equations, right? We have Q equals CV, and then we have our capacitance equals K epsilon naught A over D. And there's usually two types of questions. And usually the questions go something along these lines. We have where a battery is connected, and a battery is disconnected. And the question will go something like this. If the battery is connected, and I increase the distance between the plates, what is going to happen to the voltage? Okay? Excuse me. What's going to happen to the charge on the plates? Okay? So let's take a look at this. If I increase the distance here, we can tell these are inversely related, so the capacitance will go down. Inversely related. Now, because the battery is connected, that really is telling us that the voltage is constant. The voltage is constant. Okay? So that means in this equation, voltage is now constant. The capacitance is going down. And because the capacitance is going down, that means charge is also going to go down. So if capacitance went down by 2, charge goes down by 2. That kind of thing. So that is with the battery connected. If the battery is disconnected, so let's say we charge up a capacitor, we disconnect the battery, and then we'll say we decrease the distance between the plates. So we charge up a battery, we decrease the distance between the plates. Well, same logic. If we decrease the distance between the plates, capacitance will go up, because these are inversely related. And we go now over to this equation over here. I'll write it again so we don't get confused. When the battery is disconnected, there is a certain amount of charge on the plates, and that charge isn't going to flow. Charge cannot flow without being connected. So when the battery is disconnected, that means Q is constant. Okay, Q is constant. So if distance goes down, capacitance goes up. So capacitance is going up, and we can tell from this equation right here that Q over V equals C. Capacitance and voltage are inversely related. So if capacitance goes up, the voltage is going down based off this equation right there. So these are the most typical types of questions you're going to see with capacitance. It's not very often, at least in this course, where you have to calculate these numbers. They're more just comparing one to the other. What's going to happen when we do this to a capacitor? What's going to happen when we do this to a capacitor? What's going to happen to the capacitance? Remember that capacitance is storage, okay? If it's not totally stored, it doesn't mean the capacitance decrease. It just means the battery wasn't powerful enough. Now, I actually said earlier that I was going to do this in the next video, but I realized as I was going along, it's really not that big of a deal. We have, in a parallel plate capacitor, we have a region of space in the middle. Well, sometimes that region of space is filled with a material. So sometimes we put a material in between the two plates, and this is called a dielectric. A dielectric. I'm not sure why it's called that, but we call it a dielectric. Okay, and this dielectric basically increases the capacitance. Increases the capacitance. Okay, so depending on what the material is, will depend what the constant K is equal to. For example, um, and you would look these constants up. So example, like Teflon has a dielectric constant of 2.1. Water has a dielectric constant of 80.4. Way different. So a dielectric constant increases the capacitance. And as we can see from this equation, C equals K epsilon naught A over D. Capacitance and K are directly related. So once we put a material in between the two plates, the capacitance goes up.